What is happening, ladies and gentlemen? Today is Thursday, April 9th, 10:50 p.m. here in Colorado. The liquor of today, or the drink of today, I'm going to mix it up some here and there, do like coffee one day. But the drink of today is Dietlefs from South Africa, the Chenin Blanc. It looks like it's from the Stone Cross range. And this is a white wine. It's not too sweet, not too dry. Costs about 10-15 bucks, and it tastes pretty damn good. Anyway, continuing where we left off, we are working on the 300-410 exam for Cisco. We're going to be looking at section 2.3, configure and verify dynamic multi-point VPNs with one hub, looking specifically at 2.3 alpha and bravo. Now the IPsec, and actually we're also going to cover spoke to spoke as well, but the IPsec, and we might be covering dynamic neighbor as well on this one. But the IPsec encryption stuff is going to be for a separate video. I might talk on it briefly, but I'll have a dedicated video for that. So let's dive into this thing. I do have some Cisco material here as a reference, and again we're using EVE-NG for the topology I created here. I have all of my sessions up and running down here on the bottom right, and just to explain the topology here, we have a hub and we have spokes. The hub is also known as a server, and the spokes are also known as clients when using next hop resolution protocol. So just for some reference material, let's go ahead and look at this real quick. And all I did was search IP NHRP Cisco, and this configuration guide is available. And it's really nice because it goes in, so you really don't need textbooks nowadays. You can kind of just search the internet for everything. I mean, they're good to have, but everything's online, which is amazing. Alright, so this is talking about the iOS version. I'm not too concerned with it. The commands are pretty much the same across the different iOSs. So it's just telling you next hop resolution protocol. It dynamically maps non-broadcast multi-access. So non-broadcast multi-access. So looking at our topology here, I was referencing some Rob Riker there. But looking at the topology here, we have one physical link and a bunch of point-to-point networks here. Now, this in the real world, if this was a company, right, and they have different locations, they wouldn't have dedicated lines, connections between the hub or the server and all the remote locations, right? It's too costly. So they use one link here. So instead of sending a broadcast out to all these different clients at one time, we're doing a non-broadcast. So you have to send it specifically to a client that you're interested in sending to. So that's a non-broadcast. And then multi-access is just saying we're using one physical link to access multiple devices. This is cost saving, and it lessens the burden of configuration because you don't have to configure extra interfaces for physical cables. So it's just saying what I already said before. The server is the hub, the clients are the spokes, and it's essentially it maps your interfaces to the clients dynamically. So the server or the hub when you configure the spokes in the hub with NHRP, it creates a network, and the spoke IP addresses are shared from the hub. So the hub will tell you, oh, you want to reach spoke 2? Okay, here's the IP address, and they can do a direct connection. It's pretty nice. And I will go through the configurations here. Um, I don't really need to go through this too much. I think I covered the basics. So let's just get right into it, okay? So we have our topology here. I've already pre-configured the interfaces, the physical interfaces. These are also known as the global physical global address. These are the IP addresses that interface with the internet. So what we're going to do is we're going to go through and configure the tunnels on each of these, and we're going to show you how they communicate. So on the hub, we're going to go conf t, and we're going to say interface tunnel 0. First, we're going to set what's known as the GRE tunnel address. GRE stands for generic routing encapsulation. Essentially, what we're doing is we're taking traffic and we're encapsulating it within a virtual layer 3 address, and that's the GRE address. So we're going to say IP address 10.0.0.4. So I'm just going to configure it how I have it configured, diagrammed out on the EVNG. 255.255.255.0. We also want to make sure we say no shut, and the next command is IP NHRP map multicast dynamic. So we want that dynamic mapping for all of the devices, all the spokes. IP NHRP, we have to set a network ID, and this is going to be common across all the spokes on the NHRP network. This is how they are able to form a network. They have to match. A couple other commands. Next one is IP NHRP redirect. So what this means is when a spoke communicates to the hub, like let's say spoke 2 is trying to reach spoke 1, it's going to go through the hub, and the hub's going to say, you don't have to go through me, you can just create a dynamic tunnel yourself directly to spoke 1. So that's what that command's for. And what that does is it reduces the load and bandwidth that's being utilized on the hub. This is also important because if you don't want traffic to traverse the internet all the time, it's going to the first time when it initially communicates to the hub to get to router 1. But after the redirect, it'll no longer traverse the internet and go to the hub and then go to the spokes. So that's good. Specifically, if you don't want your information going across the internet, and you can protect it by encrypting the data and whatnot, but the other way to do it is this spoke-to-spoke communication. So that's the topic that we were talking about down here, spoke-to-spoke, and I'll demonstrate that in a little bit once we get these tunnels up. Next command is IP TCP adjust MSS, and then 1360 is what I'm going to set it at. So the reason for this, MSS is a maximum segment size, and you want to reduce this number because your MTU size is originally it's 1500, but if you are using IPsec, it's going to reduce it down to 1400, and from there the GRE encapsulation is going to add a TCP and IP header, which is 20 bytes each. So you go from 1400 down to 1360, and the reason why you want to set this is otherwise your data might not get there, it might fragment. So you want to make sure you have this command in there. Next is tunnel source, and this is going to be your global physical address. So this is the internet address that we have. There's 101.0.0.1. And then finally, tunnel mode GRE multi-point. We're just stating that we're doing the encapsulation on layer 3 with the virtual, and it's a multi-point. So we're going to have multiple connections here. Tunnel, oh, I spelled tunnel wrong, guys. It's the wine kicking in. Alright, so tunnel mode GRE multi-point. Cool. So that's the configuration that we do for the hub. So next we're going to go to router 1, and we want it to communicate. We want to configure the tunnel, but we also want to communicate to the server. So go ahead and enable conft interface tunnel 0. And then again, I'm just mapping this to what I have on the paper here, on the EVE-NG diagram. 255.0. And then this is where you have to map it to the server or the hub. So you're going to say IP NHRP map 10.0.0.4. So this is our GRE tunnel address for the hub, and then you want to map that to the internet address of the hub. So like that. So that's looking Gucci. Again, we need to make sure that we're all on the same network, which we've set as 1. And then IP, so again, you have to map it to the server, and this is going to be the GRE tunnel IP. This shortcut allows it to use the redirects, so that if you want to communicate to another spoke. And then again, you want to do the adjust size. We don't have the IPsec set up now, but in a future video I will, so I'm just going to put this on here for now, so that later it doesn't not work, I guess. Tunnel source. This is again going to be our physical address here. So we have 101.0.1.1. And then last command, tunnel mode, GRE multipoint, same as what we did on the hub. So we should, oh, and another thing you have to do here is you have to have a default route. So you have to do IP route 0.0.0.0. You have to set a default gateway here. So we're going to send everything out the IP address that we know, which is 101.0.2.2. Got to be in configure terminal, right? If you guys know a way to delete the whole line quickly, comment below. Conft IP route 0.0.0.0, 0.0.0.0, 101.0.2.2. Ooh, see, I almost messed up there. We're on router 1. 1.2. Okay. Good. So we should be able to ping 10.0.0.4. Good. And I already set up the default routes here, so we're good to go on that. That's why it's working. If not, it might not have worked. We wouldn't have known how to get back. So router 1's good. Let's go to router 2. And I'm not going to set up all 3 spokes. I'll just set up 2 and then show you how the point-to-point works as well. So conft, again, going to int tunnel 0, IP address, and then this is going to be the GRE tunnel address, 10.0.0.3, 255, ooh, 2, sorry, on router 2, 255, 255.0, and then IP NHRP map 10.0.0.4, 101.0.0.1. Again, we're mapping the hub It's GRE tunnel interface IP to the physical global address that we have. Good. IP NHRP map multicast. And again, this is going to be the interfacing address for the hub. IP NHRP, we're going to set the network, make sure it's the same as the other ones, 1. And then IP NHRP NHS, this is the server, and this is the tunnel IP, and it's .4 for the server. IP NHRP shortcut, allow it to use those redirects from the hub. IP TCP adjust 1360 for maximum segment size. Tunnel source, and then this is going to be our physical address of the spoke 2, which is 101.0.2.1. And then last command is tunnel mode GRE multipoint exit. And then IP route 0.0.0.0, 0.0.0.0, 101.0.2.2. That's the address of the ISP that's connected to router 2. Good. Now we should be able to ping 10.0.0.4. Good. Okay. So here's what I'm going to do. I'm going to show. So I'm going to clear IP and HRP, just to make sure that we're all clear. And I'm going to show you if I try to trace route to spoke 1. Let's just hit trace route, and then we can fill it in manually. Skip that. Target is .1. Can leave that there. Source is our tunnel interface, which is .2 for router 2. Numeric display yes, and then you can just skip down. So what we're going to see here is it's going to go to the server first before it goes to the spoke 1. So it went to 10.4, which is the server, and then it went to spoke 1. Okay, so now watch what happens when we do it a second time. Now, since we have redirect set up in the shortcut command on the spokes, we should just be able to trace route again, and it should go directly to the spoke. The first time it has to go to the server. So 10.0.0.1, 10. Oops, skip that. 10.0.0.2. Yes, and then just space down here. See, it went directly to. So we're all good. We can ping. Obviously, we can ping the server. We've got our tunnel up. And if you want to check it, you do. So let's go to the. I believe I might have already configured the third hub, the third router, the third spoke. So if I do show IP NHRP detail, you can see I have a connection to each spoke. It's dynamic because that's what we set up, and it has the IP addresses of the actual global address for each of those as well. So you can see everything's working, everything looks good, and that is the video for DMVPN, Dynamic Multipoint VPN, Virtual Private Network. The next video that I do will probably be on IPsec, and then once we get that going, I'll jump back to some of the other videos that we had, other sections that we were going to cover, like EIGRP, OSPF. I just wanted to get the DMVPN up, and then a lot of the labs that I've found are going over a DMVPN to do EIGRP and OSPF, so I wanted to get that up first. So I might skip around a little bit, but we'll get there. So again, we covered the 300-410 ENARSI CCNP section 2.3 configure and verify DMVPN with a single hub. We did GRE, multiple GRE. We used NHRP, and we did dynamic neighbor and spoke to spoke. So that concludes this video. Hope you guys enjoyed it. Should have another video out here in the next within the next week. Um, so stay tuned. If you like this video, please subscribe and put your comments below. Things that I can improve on. My setup will get better here. Um, I do plan on getting some recording um, devices and a better computer, better video editing software, stuff like that. So if you like this video, please subscribe and comment below. Thanks for watching.